Good evening. Our today's lecture is cluster analysis. So, let us discuss from factor analysis some analog to cluster analysis and the difference. So, if you recall factor analysis, then there you have found out that there are n number of observations and p number of manifest variables, and you created certain factors, for example f1, f2 or like these fm factors, and you try to link some of the or group some of the variables to factor 1, some other variables to factor 2, some rest variables to factor m, like this. So, that means in factor analysis necessarily you have grouped the manifest variables into different groups called factors, and you have done that with the help of observations in multivariate observations on p variables. Now, let us think little differently. Suppose I have n number of observations and all these x1 to xp, these are characteristic features for each of the observations. Now, based on these characteristic features, if you want to group the individuals into several groups, then this is known as grouping the items or grouping the individuals or grouping the observations or grouping anything. So, then this one is known as cluster analysis. Cluster analysis. The mathematics behind cluster analysis is different than the mathematics used in factor analysis. The purpose is different, the objectives what we basically serve, these are also different, but only one analogy is that it is also grouping. Like factor analysis, we want to group several variables into different factors. Here that grouping is also done, but not with respect to the variables, with respect to the observations. With this background, let me start cluster analysis, and today's discussion is we first start with certain example, then we go for what are the criteria to be considered for clustering, then I will show you some of the algorithms of clusterings, that is known as clustering algorithms, and two clustering algorithm we will be discussing. One is hierarchical agglomeratic clustering and other one is k-means clustering, and these two clustering how you will be able to run using SPSS as well as Minitab, particularly hierarchical clustering using SPSS and k-means clustering will Minitab using Minitab I will be discussing. Then I will show you one case study and conclusion. That is the totality of the presentation, and in this 1 hour lecture we will try to complete as much as possible. If something remains, it will be given in the next class. Let us define what is cluster. So, if you see the Chambers dictionary 2005, that the definition is cluster is a number of things of the same kind growing or joined together. For example, if you all of us know the different species from biology, different species. So, they are grouped together based on certain features, and they are grouped basically because of their natural similarities. For example, we can say that from food habit from point of view, the animals can be that herbivorous, omnivorous. So, 3 different kinds that can be found out, omnivorous. So, essentially then a group of homogeneous things are known as cluster. So, the principle in grouping will be like this, which is given in Kaufman and Rousseau 2005, that objects in the same group are similar to each other and objects in different groups are as dissimilar as possible. So, that is the principle. So, that means essentially what we are saying, clustering based on certain characteristics features like x1, x2 to xp, these are the features. These features will be used to group several items or objects, and the grouping is based on similarity in a group and based on dissimilarity between groups. That is the principle. So, you want to make cluster in such a manner that whatever objects or item you will be grouping in a particular cluster, say cluster 1, say there is another cluster, cluster 2, cluster 1, cluster 2, there may be another cluster, cluster 3. So, there are several items grouped, here also several items grouped, here also several items grouped. What I mean to say that the items within a group, they are as similar as possible. Then, so item between groups, this vis-a-vis this, they will be as dissimilar as possible. So, that is the what I can say principle, or I can say that is the philosophy in doing cluster analysis. Cluster analysis can be thought of a process model, and in this case you see the inputs, process and outputs model for cluster analysis. The under input, what we require two things. One is what is to be clustered, or what are the things to be clustered, and what are the criteria, or maybe one criterion or several criteria or several features that will be used to cluster. Then process is, you have to find out the way of clustering, that means you require a measure which will tell you that some of the objects or items are similar, some of the objects and items are dissimilar, hence the similar items will be joined in group 1 or in a group, and dissimilar will be in different groups, and that process is known as partitioning also. Then output of this cluster model will be several clusters or groups. Let us start with an example. The example is, the safety manager of an automobile company is interested to group the different departments based on their safety performance scores. Let there are 10 different departments, and variables that are of importance in measuring the safety performance are incident score, severity score, equipment damage score. The manager analyzed last 2 years performance of the 10 departments and arrived at the performance figures given in table 1. So, what is essentially happening here? Suppose you are a safety manager of a company and your duty is to keep people safe while working, of the work, on the work, and you have data on the performance, on the safety performance of different departments which are under your control. Over the years, you are measuring this, and then finally, what is your interest if there are many departments and there are certain key features which are similar to each of the department. So, based on those features you want to find out that whether the safety performance of all the departments are similar, or there are some departments which can be grouped, there are some other department those can also be grouped, and accordingly what will be your benefit? Your benefit will be you will take safety related decisions group wise or cluster wise. Okay. So, the data collected, for example, the 10 departments data, mean incidence scores. So, you are measuring with some measurement system, that mean incidence score, mean severity score or mean equipment damage score, and you are finding out that A, B, C, D, E, F, E, then P, Q, R, S, T, these are the name of the departments, and this is mean incidence score, mean severity score and mean equipment damage score. So, what is your purpose? You want to see that whether all those departments are performing similarly in terms of these three key features. Okay. So, let us see what we can do with this data. Immediately, what you can do with the data as a safety manager, your aim is to see individually the data. This is what is shown here, dot plots. So, we have done dot plot for mean incidence score, mean severity score and mean equipment damage score. Now, see, from mean incidence score point of view, if you see this dot plot, what you are finding out? You are finding out the two clusters, because some are extremely left side, some are extremely right side. So, it is obvious that from mean incidence score point of view, that means there are some department which are performing equally, and that is 1, 2, 3, 4, 5 departments here and 1, 2, 3, 4, 5 departments here. Okay. But if you compare any department from here and here, you will find out that there is huge difference in terms of their mean incidence scores. So, you may be tempted to say that here that okay, these are the departments where I want to take actions, similar actions here and here, similar actions for these departments, but the actions will be definitely different from this group of departments to this group of departments. But here one mistake is there, that if I go by only MIS, then I am not considering MSS and MEDS. So, you are considering individually the performance, but collectively the performance required to be considered. So, that is possible if we consider all the three features at a time. We will see little later. Let us see that from MSS point of view, what is the status of the department. From MSS point of view also, you are finding out two groups, but from equipment damage score point of view, it is difficult to tell that there are several groups. If there are several groups, then there are many groups, this one, this, or there is only one group. Okay. Now, as I told you that we have taken here only one variable, one characteristic feature at a time. Now, if we take two at a time, you will get scatter plot like this, and this scatter plot you have seen earlier also, that MIS incidence score versus severity scores, you have scattered plot. Now, see, from if I consider these two characteristics, then you are getting three clusters, but please keep in mind they are all visually just this clustering, the way I am done here, that circles, it is just seeing the that location of all the departments on this two dimensional scale. But it is obvious from here that okay, there are three clusters. Now, similarly, if I go for MIS, that is mean incidence scores versus equipment damage score, you are finding out that 2 cluster, but this one is not able to, we are not able to include in any cluster. So, then it will be an unique cluster. So, it may be again 3 clusters in that sense. Now, if you go by other one MSS, MEDS, see 2 cluster, but you may be questioning here that what is the guarantee that these are making 1 clusters, because these are spreaded through this. Okay. So, it is MEDS, but from MSS point of view they are almost at the same level, but MEDS point of view there is a huge variability. Now, if you combine them together all the 3, then you see you are getting 3 clusters. Now, question comes when there are more than 3 variables. So, your number of variable is much greater than 3. Similarly, this is the dimension. Similarly, you will go for large number, n will be large definitely. But here as we are working grouping in several in based on this is the key features, because if it becomes large, what will happen, this type of simple plot you cannot make, because even at 3 dimensional case it is difficult. So, when you go for more than 3 dimension, 4 dimension onwards, you will not be able to visualize just like this pictorial representation what you have seen here. Okay. So, what we mean to say here is definitely we are going for more number of variables or more number of characteristics of or more number of features for every items, objects, individual that we want to cluster. So, there are 2 criteria. First of all, you see that what are the variables that you must consider, and what will be your similarity or dissimilarity measures. So, under variables to be considered, it is clearly mentioned in several books, and several researchers also pointed out that you must be very careful while finding out what are the variables that you will be considering. Important variables are to be considered and trivial variables are to be discarded. Variables may be of different types based on measures like nominal, ordinal, interval and ratio. This is a very important one, because although we will not be discussing much about the data types, but if your all data are measured in interval or ratio scale, then your things become easier. That means, you will be able to get the similarity dissimilarity measures in a much better manner and in a large number of ways. But when you have nominal and ordinal data, that getting the distance is little complicated, and you have to go for those data, those techniques like chi-square, contingency table, then in case of some other measures, because where is the frequency things are coming into consideration. So, that will be a different domain from categorical, as the data is categorical, but the things become even complicated when you have the mixed data types. So, some data are nominal, some are interval, some are ratio. So, when your metric and non-metric data, both data are mixed in the characteristics features, or the variables that will be used in grouping the individuals. So, there is even problem will be manifold. Today's lecture basically we will be talking about the data, the characteristic features which are basically interval or ratio type or metric in nature. Now, then the question comes that similarity and dissimilarity measure, it is usually a measure of distance between the object to be clusters. Okay. For example, if I consider only 5 objects like A, B, C, D and E, then this side A, B, C, D and E. Now, what is required? Either you go for distance. So, if I go for distance between A and A, this will be 0. So, this will be 0, 0, 0. Okay. Now, this will be DAB, this will be DAC, this will be DAD, this will be DAE, then this one is DBC, this one is BD or DB, then this is your DBE, this one is distance CD, this is distance CE, then this will be of my distance DE. Same, upper hand also it will be the same. You must know the distance, that is D. Whether it is in general, if I say DPQ, you must have a measure to get this. Now, if you go for similarity measure, then this will change to differently. Means suppose if I say in 100 point scale similarity, then it will be 100, 100, 100, 100 and 100. And here or 1 point, if I say 1 is the most similar case, then 1, 1, 1, 1 like this, and these values also you require to find out. But actually dissimilarity similarity is just opposite to dissimilarity. Sometimes we may say 1 minus this is also my similarity measure, but there are several measures which can be used, and we will see later on. Then I will just formally introduce the data matrix in terms of X, and this is what is the data matrix for different individual, and for the case what we are discussing for this is the data matrix. So, this is what is the data we are planning to collect, and here this is the data what is already collected. Okay. And here our aim is not grouping the variables like in factor analysis, here our aim is grouping the objects with the help of the variables. What are the different distance measures? All of us know the Euclidean distance. So, if I have x and y, then suppose this is my P x1 and y1, this one my q x2 and y2. All of us know that what is the distance pq dpq. So, we can write dpq equal to square root of x1 minus x2 square plus y1 minus y2 square. Now, if you go for, that means this is like this, x1 minus x2 square plus y1 minus y2 square, this to the power half. So, if you go for, suppose there are many more dimension, that x1, x2 like xp, different dimensions are there. So, what will happen ultimately, you will get this will be extended to, that means dpq, that will be extended to your p dimensions, that to the power half. Okay. So, here you see that what I have given here, that dij xi1 minus xj1, I2 minus xj2, like this up to ip this square, this is your Euclidean distance. Okay. Many times you may be interested to provide more weightage to the distance, then you may not to go for Euclidean, you may go for squared Euclidean distance, similar to the first one, but only this to the power half is not there. So, there is another distance measure which is known as Manhattan distance. This Manhattan distance is similar to like this. Suppose you are here, you want to come here. Suppose this is my P, this is my Q. Let and this one some value, and this is also some coordinate value, 2 dimensional case. Now, the shortest one is this is the shortest one, but what you will do when you come here, suppose there is obstacle, what you will do, and this is the only way to go, you come here and then follow this. So, like this Manhattan city, and that roads, you just like Manhattan City roads, you are coming here. That means if this is O, you are first covering this distance, then this distance. Okay. So now it is what is given, that you this distance is the mod value of these things, this one plus this. So similarly, if there are more number of features or variables, you will be adding up to p features. Minkowski distance is, there is the same thing you see, but it is every distance is first powered to m, and then it is basically like geometric mean. Then you have not okay. Then you what you have done, you have basically again make it in the original scale. So all everything will be made, the sum will be made that root to the power m. Okay. Now, for the data set that what we have discussed so far, that safety data set. So, if you use Euclidean distance, you are measuring this for A2, 1 to 1, 2 to 2 like this. So, we have measured the Euclidean distance and these are the values. See, for diagonal elements are 0, of diagonal elements if having value, some of the values are high, some of the values are low, and what is required, we want basically to group these 10 departments based on this distance. If you go for squared Euclidean distance, then every item here, these are basically squared and you are getting this value. If you go for your Manhattan distance, as I told you, that obstacle is there, you have to come here and then go there. So, ultimately you will be getting this distance values 1 to 1, 1 to 1 in the sense every item to item, and or every object to object distance you are getting. Then Minkowski distance matrix, that is Manhattan distance to the power m. We are saying it is Minkowski within bracket 2, that means we are considering m equal to 2 and this is the distance. Okay. So, now then what we have done ultimately, if I go back to the process model, you will find out that we require things to or object to be clustered and we require characteristics to be measured, that we have already seen for the safety case, data case. Things are department to be clustered, characteristics are 3 characteristics, MIS, SS, MSS and MEDS, and then we want some similarity or dissimilarity measure. We are saying that we are going for the distance measure, either Euclidean or squared Euclidean or your Manhattan distance or Minkowski distance, and then what we require a partitioning algorithm. So, there are hierarchical joining algorithm, non-hierarchical algorithm. Hierarchical algorithms are hierarchical agglomerative net clustering algorithm, and non-hierarchical algorithm like k-means clustering algorithm, all those things are there. So, first we will discuss about the hierarchical algorithm, joining algorithms. Okay. There are many ways to group objects in hierarchical joining algorithms. The names are single linkage or nearest neighbor algorithm, complete linkage or farthest neighbor, centroid linkage, then average linkage, median linkage and word linkage. So, these are the different types of algorithm for joining the objects into different groups. Let us first understand what is single linkage algorithms. Single linkage algorithm is here distance between two clusters are distance between two closest member of the two clusters. For example, you just think of a two dimensional case where all the objects here or items are put in the appropriate location based on the characteristic features of that two dimensional data matrix. Now, you see that arbitrarily I have given some groups. This is one group, this is another group, this is another group. So, we are saying this is your cluster 1, this is your cluster 2 and this is your cluster 3. Now, question comes, how do I make these groups or how do you can make this group? Here if you are talking about single linkage, then you are talking about the distance between cluster 1 and cluster 3 is the distance between the two nearest objects of the two clusters. So, obviously this one. Now, you may be wondering that there is no cluster started, then how suddenly you make this cluster and ultimately how these things are coming. So, that I will discuss little later, but you first you just understand here little abstraction you make that okay, it is there is cluster, different clusters possible, and the distance in single linkage means the distance between the two clusters is the nearest neighbors, distance between the nearest neighbors. Now, when you talk about the complete linkage, you are talking about the furthest neighbor. That means you find out the member in cluster 3 for example in this case and member in cluster 2 who are the farthest point. It is not, they are not nearest, they are the farthest, the maximum distance where they are. Then when we are talking about centroid, you see the distance between two clusters is distance between multivariate means of the clusters. So, there are several variables here, actually two variables are there. You are basically considering the data mean value for each of the variables and then accordingly you are making the centroid and then finding out where it is. So, let me write down then that we have joining algorithm like single linkage, complete linkage, centroid, then you see that average linkage, then median linkage, then word. Now, if you see the average, then you come here, you see the distance between two cluster is average distance between all members of the two clusters. Okay. So, there are so many members items here and so many items here. You find out the average of these items, and then find out the distance. And median case, it is median distance between all members of the cluster. So, all of you know median. So, find out the distance and then get the arrange from smallest to largest and get the median value. What distance? That average distance between all members of the two cluster with adjustment for covariances. Actually, if you can recall that when we have discussed the statistical distance, I say when if you consider Euclidean distance that all points on this circle are similar in terms of Euclidean distance, but if there is suppose an ellipse, the data resemble ellipse, you cannot say based on Euclidean distance they are equidistant, but if you see that Mahalanobis distance, then what is happening here that all points on the ellipse are equidistant because the variability across x1 and variability across x2 these are weighted, and that is why you got like this that x minus mu transpose sigma inverse. I think here we will use Mahalanobis S inverse x minus mu. Okay. So, if I write the one variable this, then this is my di square, that is I j, then j, then ij, then j. Just similar manner that ij or di square, you write xi, that is straight away the multivariate observation, then you write mu here, here I and mu, that is better. So, here in word linkage what happened, that the two cluster with the adjustment covariances, here it is the adjustment of variances and covariances in terms of S inverse. S inverse, it is what distance is similar to this, because you see that their adjustment of covariance between one variable to another variable. So, these are nothing but to find out distances, and these are applicable only when you have made groups. Suppose you have not made any group, there are some observations 1 to n and you know the distances. For example, A, B, C and A, B, C. So, you found out the distances, this is 0, 0 and 0. Suppose this distance is 2, this is 5 and this distance is again 3. Here what you will do first, you first find out the smallest distance. This is my smallest distance. So, these two can be grouped, A and B can be grouped. So, if I do this, then what happen, your now data set, initially data set when it is not grouped, everything is a cluster, A is cluster, B is cluster, C is cluster. When it is grouped, A B becomes one cluster and that C remains, then A B and C that remains. Now, A B to A B will be 0 and C to C will be 0. What will be the distance between A B and C? There you have to choose, you can select any one of this method and then find out. For example, if you use complete linkage, single linkage let it be, if you use single linkage which is basically known as nearest neighbor, then what is required, you find out the distance between A and C, distance between B and C, then find out what is the minimum value. If I go for this A and C, this is 5, B and C, this is 3, then definitely 3 is the minimum. So, your distance is 3 if you go for single linkage. If you go for complete linkage, that is farthest neighbor, then what will happen ultimately, you will find out that the maximum of these two will be taken. So, similarly for centroid, average, and the criteria are given and we have to do this. Now, I will show you on this one after another. Now, what are the steps? Steps to follow in hierarchical clustering. Step 1, identify the variables and objects. Then you have to collect data, then select similarity or dissimilarity measures what you want. Usually we go for dissimilarity measure, distance. Then obtain the distance matrix. Start with n clusters. Please keep in mind, we are saying that individual items or the objects or the what I can say things that you are trying to group, they are unique. So, if there are n objects, n clusters, starting point is n objects, n clusters, then you see the distance from here for every distance you are seeing. You find out the minimum distance and then you group. So, if these two are minimum, then this will be grouped, then things will be coming like this. So, when we are talking about hierarchical agglomerative clustering, what is happening? Initially there are n objects. So, when you group one only the two of the original n, they are grouped, now there will be n minus 1 cluster. So, if I say the number of cluster here is n, here clusters are n minus 1. So, in this manner your things will be reducing n minus 2 like this, finally there will be one cluster, where all will be grouped. So, that is what is required to be done here in hierarchical clustering. So, first you find out the distance. So, you take each one a cluster, find out the distance between the cluster, and then you take every pair of clusters from that things, and then you think that the most similar clusters are P Q, and this can be grouped, that like this. If this is P, this is Q, suppose this is your M, what is happened? This is most similar. So, these two are grouped, these two are grouped. When you group two similar objects, so your number of clusters reduced to n minus 1, that is what is given here. Merge cluster P and Q and label the newly formed cluster as P Q, update the entries of the distance matrix by matrix D by doing these things. So, deleting the rows and columns corresponding to cluster P and Q. Basically, if I have 5 items, so and you find out that A, B are most similar at the first level, distance is less, then your number of cluster initially n equal to 5. Now, these two will be grouped, then C, D, E, then A, B, C, D and E. So, now cluster is here n minus 1, that is 4. Now, what will be the entries, that means the distance values. Original distance is d n cross n, now it will be d n minus 1 cross n minus 1. We have to find out this, that is what is said here, that deleting the rows and columns corresponding to cluster P and Q, here A and B. So, A rows you delete, okay. Then adding a row and column giving the distance between the P Q. So, like A B, you are adding one row and column, one row for this you are adding, one column also you are adding. So, you are deleting 2 here, 2 rows 2 columns, adding 1 rows 1 columns, and ultimately n minus 2 plus 1, that is n minus 1 is coming here. Okay. Then you repeat what you have done in step number 6 and step number 7 for all n minus 1 times. When all the objects are grouped, means when you are coming, you have to go up to this one cluster level. When you are reaching there, so you stop. Then final one is record the identity of clusters that are merged at the levels at which the merger takes place. So, from the in level, what will happen ultimately, you will find out a situation that from your in levels, you will basically suppose first you merge these two, then let you merge this one. So, then let you merge another 2 here, then finally suppose you are merging these 2, maybe another one here, then let the final merger is coming to place here. This is the final one cluster, this is n cluster. So long you are not coming to this, you are not stopping. These are objects. Then object to groups, then final this is happening. Now, where you will be stopping, that all depends on what is the distance between the objects in a group, the maximum distance between the objects in a group, or the single linkage, that single linkage will come between groups, but for distance between in the same group, the maximum distance you will say that you are accepting or not. Okay. So, then what will happen, as you are going up to lower number of clusters, actually distance between the objects within a clusters within a cluster is increasing, for every cluster it is increasing, but after certain distance you may not accept that distance. So, this is little difficult to understand, but if I go by similarity measure, what I mean to say that if I make cluster here, then this is my one cluster, second cluster, third and 4. 1, I think this one is taken care of. If I come here, these 3 are taken care of, you are making 2 clusters. So, then you see that what is the similarity measures of all these objects within this cluster, and here it is 1, then that is the 100% similarity measure. If similarity reduces from, that means here it is 100% similarity, now slowly it will reduce, it may be, you have to find out here how much it is it 50%, is it 10%, is it 0%, is it 70%, what you want to keep. Suppose at this level if it is 70%, are you happy with 70% similarity between the objects within a group? If you are happy, in this case you can keep 2 clusters. All items here things are such that all the items except this one are grouped under cluster 1 and this is cluster 2. Okay. So, that is step 9, record the identity of cluster that are merged at the levels at which the merger take place. Now, based on this value you can give some identity, that is cluster 1, it may be you give some other interpretable identity, and maybe these groups are of some type, this group is of another type. For example, from safety point of view, the example I have given, maybe these are low accident prone situation or departments, and this is the high accident prone situation. So, that means the 2 cluster, low accident group department, high accident group department, low, medium, high, in many ways you can find out. Now, I am explaining here how this actually nearest neighbor or single linkage is working. The same example, similar example I have already given you, but it is more formally. You just see the example and try to understand fully that there are 5 objects and this is distance measure. At the first instance, what you require to do, you have to find out which one is the smallest, which pair of objects are having the least distance. Here the 2, this 2 is the least distance value among these values. Forget about 0, because we are talking about item to item distance, not the same item, because same item distance is 0 always, same item distance to that item it will be 0, but we are talking about the other thing. So, it is 2. So, 2 is 3 and 5, the distance between 3 and 5 is 2. So, see 5 3 are grouped here, 5 3 grouped here. What we have done, you deleted this column as well as this column and you added one column, one row and one column here. So, one row here, this column as well as this row you have deleted, and similarly that means what I can say, that 3 and 5. So, this one 3, this 3 and 5, then 3 and 5, this 2 will be deleted and one more will be added here. Now, question is what is the distance between the cluster 5 3 and 1. So, the nearest neighbor says that you find out the distance between 1 and 5 and 1 and 3, take the minimum one, then 1 and 5 is 11 and 1 and 3 is 3. So, minimum one is 3, you have taken 3, and rest of the items the distance similarly 5 3 versus 2, similarly 5 3 versus 4 you have to find out. So, 5 3 versus 2, that means 2 5 and 2 3. Now, if you go by 2 and 3, this is 7, then you require to find out 2 and 5, the 2 have 5 7 10. So, the minimum of 7 and 10 is 7. So, it is coming 7. So, similarly 8, rest of these things are already available here, just because this is 2 to 1 and 2 to 4 and 1 to 4, the distance already it is here. So, if I say 1 to 2, that is 9, 9 is even here like this. So, your new distance matrix is this. Now, what you want here? You want to find out that what are the members or objects that can be grouped further. So, here 5 3 is one object or one group. So, we will be treating as one object. Okay. So, then what we will do? We will again find out which one is the minimum value, distance value. So, here you see out of these 3 is minimum, it is 5 3 and 1. So, here you are, that is why in this case 5 3 1 is grouped and 2 4 remains. So, that means how many clusters you are making here? You are making here 1 3 5 one group, 2 one another group, 4 another group. So, ultimately it is 3 clusters. In cluster, if I say this is my cluster 1, then in this case 1 3 5 of these 3 objects are grouped, then cluster 2 is having only one object, that is number 2 object, and class 3 is having only 4 objects. Now, distance, if you see here, see we are using single linkage. So, in the first case, when there is no groups in the sense that no 2 objects are in one group, here every object is representing one group. In that case, there is no distance, the 0, the diagonal elements. When I come to this 4 cluster, this second this table, then you find out that what is the minimum distance between, what is this distance 3 and 5, the distance between this. So, there are 2 items. So, you are getting one distance, that is 2. Now, come to the third one, when the 3 members are grouped under one cluster 5 3 1, then the distance we are talking about the 3, because it is coming from this 5 3 1. So, it is not that we are taking the maximum one, it all depends on which linkage you are using. Okay. So, earlier I said the maximum one, that also possible when you go for complete linkage. Okay. So, 3, then what will happen here, you will find out again the similar table will come and you find out that 2 4 will be grouped. So, the 2 cluster 1 3 5 one cluster and 2 4 another cluster, and the distance is 5, and finally, one cluster and distance is 6. This is the minimum distance between the members of this. Okay. Now, see that same thing can be represented in a diagram like this. Here, when distance is 0, all the objects are forming one cluster each. There are 5 objects, so 5 clusters. So, at the distance level 1, no grouping possible, only at the distance level 2, 5 3 are grouped. So, at this level you are sacrificing a distance or dissimilarity of 2 between these 2 members, and but in this process you are gaining one way, that way is your number of clusters reduced from 5 to 4, and at the distance of 3 your number of clusters reduced to 3, and but your distance sacrificing distance is 3, and but at the distance of 4 it is not like this, nothing possible, but at the distance of 5 you are making 2 clusters, at the distance of 6 you are making 1 cluster. What is this diagram known? This diagram is known as dendrogram. Okay, actually this is what I told you, the same diagram, it is just 90° rotated there. So, this is known as dendrogram. Okay. So, then you see that we will go for complete linkage with the same example, and you see that the object is, the process steps are similar except the calculation of the distance measure. The distance will be here the maximum distance between the members of the groups, 2 groups. In that case, if you go on grouping, your grouping is 5 3 again first, then your 2 and 4, then finally 1 is coming, and finally all will be grouped. But here distance measure, if you see that you are sacrificing how much distance, 11 distance for one group, because here you have considered the maximum distance, and you see this table, here is the maximum distance is 11. Okay. So, but if I compare this with the earlier one, here also we found out that 5 3 final one, if you say that 5 that the second one 5 3 and 1 2 4, here 5 3 and 1 2 4, but the difference is coming here 1 3 5 is grouped and then 2 4 remain as it is, but here 3 5 and 2 4 again grouped, and so that means there will be change in the dendrogram in grouping. And it may so happen that you may not get that exact grouping if you go for by exact grouping, what I mean to the same grouping if you go for different linkages. If you go for single linkage, you may get some type of grouping, you go for compare linkage some other grouping. If you go for average linkage like this, it is a different example, other example you are also getting a different grouping. But please keep in mind, the message is that if you can calculate the distance between the objects within a group and between the groups also, that is also required, because we require similarity as well as we require highest level of dissimilarity. So, then using this hierarchical clustering algorithm, you will be able to find out the dendrogram and what level of similarity or distance you want to keep, the what I can say, you want to have this amount of similarity, you are satisfied with this amount of similarity, and then fine, you go for that level. So, what I will do in the next class, I will continue this cluster analysis, I will go for some other algorithms, and then for hierarchical clustering, and then we will discuss k-mean clustering. Then we will see one case study and using SPSS and using Minitab, how it can be done. Thank you very much.